All right, can you guys confirm that you can see my screen?
Yes.
I can.
Yep.
I would like to welcome everybody to our virtual Vancouver hardware meetup. I would like to give a little bit of background about these events. My name is Madison. I am the organizer of Vancouver Hardware Meetups. We are a forum for local hardware developers, product developers, engineers, makers, entrepreneurs, and budding angels to pull together minds from all corners of the hardware community in Vancouver to help connect makers to funders. Since last year, we have moved to a virtual format, which has been allowing us to expand our reach and get out to a wider audience. We do have a code of conduct for our events. We are committed to providing a harassment-free experience for everyone at our events, regardless of gender, gender identity and expression, sexual orientation, disability, physical appearance, body size, race, age, or religion. Any comments in our live chat of a harassing nature will not be tolerated, and anyone violating these rules will be removed from the discussion. And to give you a little bit of background on myself and MistyWest. MistyWest is a Vancouver-based engineering design consultancy that exists to create novel technologies that enable a healthier planet and bring prosperity to all humankind. My role at MistyWest is our content creator and community manager. So I am responsible for some of our events and as well as our blog content and a lot of other external facing engagement that you see from MistyWest can come from me. Today's event is the good, the bad, and the optimized asset tracker. We have our senior Bluetooth engineer, Kevin Lockwood, joining us, as well as two representatives from Nordic. We have Michael Sly, who is a field application, is it Sly or Slee?
Sly, you got it right, Sly.
Okay, good. A field application engineer at Nordic, as well as Chris Hansen, director of IoT labs at Nordic. I already gave you a brief introduction on who I am, and I'm going to be moderating the Q&A towards the end of the discussion. We're going to set aside a couple minutes after I finish this presentation of the panelists introduce themselves, and then we have a presentation on what is an asset tracker, so you will get more understanding of the different applications and different options you have for your IoT engineering. The remainder of the session will be dedicated to the audience Q&A, some thank yous, and then a couple announcements from MistyWest. So that is it for my introduction. We hope that you join our Vancouver Hardware Meetups meetup group, and yeah, follow us on Instagram, Twitter, and use the hashtag Vancouver Hardware Meetup. So I am going to stop sharing my screen, and then Kevin, if you would like to go first with the introductions. I think you're muted.
Of course I am. Okay. Hi, my name is Kevin Lockwood. As mentioned, I'm the senior Bluetooth and firmware systems engineer here at MistyWest. I've been working in wireless technologies since about 2008, back in the old 2G days. So asset tracking has always been a use case that has been a part of my engineering life. And there's a very good reason why, for the purposes of this presentation, we're going to focus on an asset tracker. Reason being that if you can master designing an asset tracker with this technology, you can do almost anything. I'll pass it over to Mike.
Hi, I'm Mike Sly. I am based out of Southern California. I'm one of about 15 field application engineers in North America, supporting primarily customers in my region, which is the West Coast, all the way from Vancouver up in Canada down to Mexico. And we also have a big support team, our application team in Norway and Finland, who support customers via our dev zone. So that's what I do. And I'll pass it over to Chris Hansen.
Hello, my name is Chris. Chris Hansen. I'm based in Portland, Oregon. I work for Nordic Semiconductor. I'm a director for our IoT group here. The main product that we build here is in our cloud. Is the free tool that Nordic has for people that want to connect their Nordic devices to the cloud. We see a lot of usage for asset trackers. It's really a big thing, and so we have special support in the cloud for asset tracker applications. That's it for me.
Thanks, guys. So just to give a quick bit more context to MistyWest, as Madison mentioned, we're a design consultant firm out of Vancouver. We work for anywhere from your 2 to 3 person startup companies all the way to several Fortune 500 companies. Our core expertise in technology lies in optics, embedded vision, cloud IoT, low power electronics, and wireless connectivity. So anything from Bluetooth, Wi-Fi, cellular, and satellite technologies. Why an asset tracker? So when we look at the landscape of technology, especially as a design consulting firm, we sort of have to look at what are the emerging trends and what are the growing technologies. And when it comes to the underlying technology for most asset trackers, you can see just substantial growth over the next few years. And it's only going to continue with the potential of what these technologies can unlock, both on the 5G side, as well as on the lower end, lower data end on NB-IoT and Cat M1 side. There's just endless applications, anywhere from tracking shipping and packages, consumer retail. Health is a largely growing sector where cellular technology was never really viable in the health space before, as well as livestock and pet tracking and machinery in the industrial sector. There's a few basic requirements for any sort of asset tracker, and for modern day, we'll go through 5 of them. So we have real-time connectivity, which means that a device can receive data from the cloud or internet. It can send data to or from the cloud, and has to be able to do these operations with an acceptable latency. And obviously, the trade-off is always the lower latency, the higher the power. It also requires cloud solutions, so you can manage your assets, manage the data from those assets. You can manage firmware over-the-air upgrades, which is pretty much a standard feature over any wireless technology nowadays, as well as device provisioning. There's no way you can be able to manage thousands and hundreds of thousands of assets without a cloud solution imposed. Location tracking. Not all asset tracking requires location tracking, but for the purposes of this discussion, we want to include it because it presents an interesting design challenge and interesting solutions around those design challenges. So this includes outdoor geolocation of the asset, indoor tracking, and acceptable accuracy of the imposed technologies. Any asset tracker is going to have sensors. It's almost becoming a standard that any asset tracker will have motion tracking. The power consumption of these sensors is so low that it's within the noise of the idle consumption of these devices. You might as well include it. Similar to temperature sensors, they consume so low power and it provides such valuable data that you see existing in almost every single asset tracker. And pressure sensors are an emerging one as well, because they can help you determine altitude or floor detection if you're in an indoor environment. And for now, ubiquitously, asset trackers use batteries. And especially when you have wireless technology, you deal with high peak currents. You deal with products that need to be in the field in the order of years, and they're generally not rechargeable. And there's always a trade-off. More capacity equals a larger size. Sales is always going to tell you got to make this smaller, and engineers are always going to say, well, we need a bigger battery. So it's the battle that's as old as time. So as mentioned, it requires the optimization of all of these components, and that's really why we want to cover an asset tracker for the purposes of this presentation. And the thing we will demonstrate from this is there's no free lunch, but there are definitely discounts when it comes to designing in the cellular IoT space and how we can balance performance versus battery life. So these are the 7 requirements that we're going to cover in today's presentation. So we have wireless connectivity that we'll say for the purposes of this presentation requires multi-city coverage. We're going to need real-time tracking with an acceptable latency. I'll have to have a cloud solution imposed, location tracking of the asset, battery powered, we're going to say over 2 years of battery life for the purposes of this design, low data cost, and small size. So starting with wireless connectivity, when we look at the range of what would entail this, for purposes of most networks, we're going to arbitrarily choose that the range will need to be over 5 kilometers. So this really rules out any of our standard short range technologies, like your Wi-Fi, your Bluetooth. We're going to have to go long range for an application like this. So first one, the best technology in terms of global coverage is going to be satellite, but you're going to be saddled with a couple of hard limitations. We'll have high power requirements, of high data costs. I mean, 0.45 cents per message, which kind of reminds me of the text message rates that I used to have about 15 years ago. And if you have 12 messages per month, 12 messages per day, that's going to run you in the hundreds of dollars per month. It's not viable for an asset tracker for most applications. And we keep hearing about Starlink. Starlink is not going to be viable for asset tracker, and I'm happy to answer why in the Q&A section. But for the purposes of time, I'm just going to say that it's not viable for this. A lot of people look to some of the sub-gig technologies like LoRaWAN or Sigfox. However, there are no existing networks outside of some limited application of Sigfox in Europe. So you can't really leverage an existing network, which requires an expensive infrastructure that you need to implement. It's just not going to be realistic for any company to come in and design their own asset tracker. So that really leaves us with cellular. And the landscape of cellular, we still have 2G and 3G. There is your standard LTE bands. 5G is the emerging technology. And we have Cat M1 and NB-IoT. As you can see, on the lower data rate side of things, that's where we have our 2G and NB-IoT and LTE Cat M1. And these are really the data rates that you're going to need for an asset tracker. We're not generally streaming data from an asset tracker. You're streaming location, maybe some sensor values, perhaps some battery level data, but we're not a high data throughput application. So that kind of rules out the requirement from 4G and 5G. And you can also see that these are not low power technologies. Now, back in my old asset tracking days, what we would used to do is on the 2G or 3G networks, we would have our modem completely off. We would turn it on when we needed it. We would search for a network. We would connect to the internet and send and receive data and then power a modem off. And this is the way that asset trackers were designed for many, many years. And the range for these technologies is about 5 to 8 kilometers, which is fine for urban dense environments. But as you move out to the city, those ranges can sometimes be a bit limiting. I mean, anybody in Vancouver will know that your cell coverage drops right out as soon as you're on the Coquihalla. But there are also issues with this approach. Namely, when you're turning on and you're searching for a network from a powered off state, this is one of the most high power consuming events that a modem can go through. And this can have an adverse effect on both your battery requirements and your battery chemistry, because it can take up to 30 seconds sometimes to reach the network. And that will eventually affect how your battery operates at the lower end of its capacity. The other issues with this is we're seeing the sun setting finally on the 2G and 3G networks. These have been suggested by a lot of the carriers for many, many years, but with the final emergence of 5G, there is a business case for why these networks are going to be shut down, and thus it's really not a recommended technology for a new product. So that really brings us into NB-IoT and LTE Cat M1. They have both the range that we're looking for, in fact, almost twice the range of standard LTE technologies, and extremely low power consumption. As you can see, the floor consumption on LTE Cat M1 in a specific mode is in around the Bluetooth low energy range in terms of microamps. NB-IoT is a little bit lower, and the cost of the hardware is actually lower than current LTE standard modems. One of the issues with NB-IoT is that it doesn't support mobility, which is very important for an asset tracker. What that means is that it doesn't support tower handoff. So if your device is moving along the highway, you're going to have to be connecting and handing over to several different towers as you move down the road. And that isn't supported on NB-IoT. Its best application is for stationary products, which really means that LTE Cat M1, from all the solutions that I've presented, is definitely our best solution for an asset tracker. So just to quickly summarize, Iridium, which is the satellite technology, has very high power consumption and has high data rates and hardware costs. On the LoRaWAN side, we have to implement our own infrastructure and gateways, which can cost quite a bit of money. Our standard Cat M1 LTE technology has a higher power consumption, and it's just on the border of the kind of range that we'll likely be looking for an asset tracker. And similar issues with 2G, as well as globally, these networks are being shut down and the spectrums are being repurposed. NB-IoT, again, mobility is not supported. So the natural conclusion is Cat M1 is definitely our best option for an asset tracker moving forward. And I'll just sort of give you a quick overview of why these types of technologies, NB-IoT and Cat M1, are so great in terms of power consumption. So everybody has a phone in their pocket right now, and that phone is paging the network every 1.28 seconds, sometimes less, sometimes more, depending on what the modem is actually doing. But that's how often it is connected to your closest cell tower. But with LTE Cat M1 and NB-IoT, there are modes that we can enter where we can vastly extend what's called these paging intervals. So that instead of contacting the network every 1.28 seconds, we can extend that to between 10.24 seconds to this resolves to up to 40 minutes. And so you can see that the device can be in a sleep mode for most of this time and thus drastically save power. Of course, it does have the impact of reducing data rates, but for an asset tracker, again, we're not streaming data. We're not streaming a ton of data. Most of the time, we want to be able to be in a low power state to save battery life. So in what's called extended discontinuous reception mode, or EDRX as I'll refer to it, most of the time our device will be in a low power sleep. We can wake up and listen to the network in case there's any new data from the cloud. And if we need, we can transfer data to the cloud, which obviously is a more high power consuming event. The time cost to wake up a device from sleep is about 1 millisecond to wake up and listen. So it's a very fast wake up, far faster than the previous slide I showed you, where if you're turning a 2G or 3G modem on from a power off state, that could take up to 30 seconds. So as you can see, it's a much faster, much lower power consumption event. There's also power saving mode, which if we need to extend beyond the 40-minute limit of EDRX, then you would use power savings mode. It allows you to operate in a deeper sleep mode than EDRX, so the idle current is lower. However, it costs more power and time to wake up the device to reconnect with the network. So there's always going to be an inflection point here. Which of these modes do I choose? Do I choose the PSM mode, which has a lower idle current, or the EDRX mode, which is higher but costs less to wake up? And what we really find is that the inflection point is in and around 6 hours. If we are in an asset tracker application, we're likely going to be contacting the cloud more often than 6 hours. It's possible there are some niche applications, like in a device in a shipping container, where over the 6 hours is fine, and in which case you would choose PSM. But for the purposes of today, EDRX is definitely our preferred mode to go with. And just to give you a quick power analysis example, if we are uploading data approximately every 6 minutes or 11 minutes, and we're listening from the network every about 5.5 minutes, our total radio average consumption is about 70 micrograms, which is again in and around the range of a medium data rate Bluetooth low energy application. So it really kind of puts into perspective how low a power you're able to get out of this long range wireless technology. But there are challenges with this. This is an emerging technology, and these are some of the challenges that we're going to face as we design asset trackers. So when it comes to cellular, the network controls the connection and controls the connection parameters. So what that means is that when we connect to a tower or device, these PSM modes and EDRX modes might actually not be supported by the tower. It really depends on the network, and it really depends on the tower. And even within that, they will have their own imposed limitations on how long you can set your sleep intervals in either PSM or EDRX. So because of this, how do you design around that? Furthermore, roaming sims sometimes don't necessarily support these modes. So you really need to know your provider. And the support for EDRX and PSM, it varies location to location and tower to tower. So it's really important that when you're designing an asset tracker, you take into account that it's not just turning on a modem and connecting to a network. You need to know who you're connecting with, and you need to understand there may be limitations with whatever SIM card carrier or SIM card provider you are currently using. There's unlocked SIMs and there's network locked SIMs, which are location specific, and all of these will play a factor into the portability of what you're able to do with this technology. One of the SIM card providers that we use a lot at MistyWest is iBasis. They have global support for these bands, the LTE-M and NB-IoT. As you can see, it's available on all these countries and more. But you can also see that there, for example, in Toronto, there are areas where, although you can connect over LTE-M, they currently do not support some of the EDRX and PSM features. This is an older graph, so I believe this has been updated, but there are, as you can see, also limitations on what you can set your intervals to. So all this data is really important that it's be able to be tracked by your device when it's in the field. So one design tip for getting around this is dynamically selecting what network you're on. So as we mentioned, MistyWest likes to use iBasis SIMs. And what that allows us to do is to select what network we actually want to run on. Now, being able to have this sort of portability will incur some higher costs, because if you're on a locked SIM to a locked network, they'll give you a better data rate or data cost than an unlocked SIM. But what this does is, as an example, if we connect to a Bell tower and we see that the PSM and EDRX modes are not supported on that tower, if we have an unlocked SIM, we can choose to disconnect from that network and try the closest TELUS tower. And if the closest TELUS tower does support those modes, then that's the tower we connect to. So having a layer of dynamic network selection in your asset tracker really gives you an immunity to some of the limitations on the fact that this is still an emerging technology. It's also important to note that you want to be able to notify your cloud when you're connecting to a tower that doesn't support the types of intervals and modes that you're trying to impose. One of the requirements we had is low data costs. And so again, using non-network locked SIMs, though can maximize interoperability as mentioned, it will incur slightly higher data costs than locked SIMs, but we're still talking in the cents range. So to give you a range of data costs, it's between, in a lot of cases, 12 to 80 cents per megabyte per device. So again, an asset tracker is not transmitting more than 100 or hundreds of bytes per update. So you're still talking in the sense of data cost per device. And these costs actually go down the more SIM cards you buy, and depends on what your contract is with your SIM card provider. But this just gives you a range of the fact that the data costs are quite low, and as you can see, orders of magnitude lower than any sort of satellite solution. So the next requirement we'll look at is real-time tracking with acceptable latency. One design tip that we've used at MistyWest is to have a couple different modes on any cellular IoT application. So for the purposes of this, we're going to have a secure mode and insecure mode for our asset tracker. So secure mode would be an asset tracker where it's in a known location within, say, a geofence, and we don't really need to update the cloud as often because we're confident of where its current state is. So if we set an update interval of, say, once per hour, and we connect with a network every 11 minutes to see if there's any updates from the cloud, we can be down to around 18.69 microamps, which works out to about 7 years on 2 AAA batteries. So more than meets our power requirements. It's beyond the point where in 7 years, technology is going to have changed so much, you're going to want to redesign your product anyways. Then we have insecure mode. So this is sort of where you're not really sure where the device is, or it's outside of a geofence, or maybe it's in a state where you simply need to track it more. So you can have your device have different update intervals and different IDRX paging intervals so that you can reduce the latency to your device. And obviously, the lower the latency, the higher the power consumption. So these this 4-minute update interval and approximately 2.5 2.5 minute cloud paging interval, that gets us to around 185.71 microamps. So 9 months on 2 AAA batteries is not the worst, but it definitely doesn't meet our power requirements. But if you look at switching between these two modes or having a multi-mode, let's say we're operating at 80% in secure mode and the device is around 20% in insecure mode, we're down to about 52.09 microamps, which gets us around 2.5 years on 2 AAA. So this allows you to have the low latency when you need it, or adapt to a longer interval when you don't need it, and you can meet your power requirements. Another important note is that you want the cloud to always be notified of what you're currently connected to in terms of parameters, as well as what mode your device is in. So let's say we are currently, we want the cloud to update our device into a lower latency mode. So as you can see, let's say we change our update interval to 40 seconds and our paging interval to 10.24 seconds. So definitely higher power consumption than the other modes that we had talked about. And our power consumption is around 41 days. And if our device is then entered into a more secure location and we're deciding that, you know, higher latency is fine, we can then have the cloud direct us to change our update intervals and then thus reduce our power consumption. So not only having the device make decisions based on what latency mode it wants to be in, but allowing the cloud to make those decisions as well allows you to have large-scale management of your assets when they're in the field. So the next step would be, well, we need a cloud solution. We need a way of being able to track all this. So devices connecting over LTE will always have a backend, and there's several to choose from. We have Google Cloud Platform, AWS IoT, Microsoft Azure. Nordic has their own NRF Connect for Cloud, very powerful for getting up and running. And all these backends allow you to do configuration management, firmware over-the-air updates. There's messaging and telemetry status. There's pipelinings and APIs you can do, and there's tons of tools available and different features available on these different platforms. It also allows you to do visualization and fleet management of all your connected devices. I'm not going to go through this slide too much in detail because this isn't necessarily a cloud presentation, but it kind of gives you the overall feel for all the potential usage for a cloud connection with an asset tracker. So everything from secure communication, telemetry messaging, you can do device twin management, so you can make sure that you set all your device configurations, firmware over-the-air updates. You can again connect this to end fleet management, create dashboards. There's almost unlimited potential once you connect a device to one of these standard cloud platforms. And a design tip for this is all cloud solutions are all going to have their benefits. They're all going to have limitations. Some are easy to spin up, but much less customizable. For example, Azure IoT Central, very easy to get up and running and spinning, but there's going to be limitations with the kinds of features you can impose. There's also going to be under the hood limitations with each platform. For example, Azure has a maximum MQTT interval of 15 minutes. If you need to keep an MQTT connection alive longer, and you're going to be limited by this this interval. So really, it's always best to go with what you know best, because you're going to discover these as you dive deeper into these solutions. The fastest is probably the NRF Cloud for getting up and running. The connectivity is already there for all of the Nordic development platforms, and SIM card provisioning is already integrated, which is a big step for getting devices in the field. I'm going to hand this over to the Nordic guys, and they can do a summary on the NRF Connect for Cloud.
You got this one, Chris?
Sure, I can start off. Hi, I'm Chris. I'm just talking a little bit about NRF Cloud. Like Kevin said, we have a bunch of features on our NRF Connect for Cloud tool to get people started working on asset tracker technology. Before you decide to create your own cloud solution, you get started very quickly using NRF Connect for Cloud. There's a whole bunch of stuff listed here on you can see I mean, it's designed mostly for developers at this point. So there's a lot of data coming out of the cloud that you would see like for development data and all your messaging and stuff like that. Then you can tweak your data there and get a lot of your power consumption numbers down that Kevin talked about, and see it actually really working on a real cloud solution without having to deal with all this stuff on other cloud solutions. So this is a good tool to get started with your asset tracker example. One thing we're going to talk about a little later on, I think, in the slide deck is about assisted GPS and predictive assistance too, which is super important to get your asset tracker long life. Yes, you go on the next slide.
So I'll add some color here. So basically, to get a position fix, you need to have current satellite data in your device. So both the almanac and the ephemeris data, and you can see from this slide that the almanac's usually valid for up to a week, as many days, where the ephemeris will go stale after a few hours, depending on when you last got that data in. So to get a quick fix, or what we call a hot start or hot fix, you need to have valid data. So there's a couple of ways to get it. The traditional way is to get that satellite data straight from the satellites, but the link is very slow. It's 50 bits per second. You're not using up any of your data on your SIM, but you're taking a long time and you're running a lot of power on your end device, which is what you don't want to do. So there's alternatives for that, and one of them is HEPS, which we'll talk about as we move forward here. And you can see, a cold start could take up to 12 minutes. It could take longer than that. And your current is going to be, somewhere between 0.6 milliamps. And if it takes a long time, if you don't have data, it could take up to 8 milliamps. So you're running a lot of current on your device, which is something you don't want to do. You really would like to start off in a hot start condition. You can see the warm start. Typically, if you've been using the device for a certain amount of time, less than an hour, or less than that, you're going to have a warm start. You'll get up quickly, less than a minute, but you'll still use a lot more current to get there than you would if you had a hot start. Again, we're kind of showing what happens when you start using assisted GPS. And assisted GPS essentially means you're getting this ephemeris data from using LTM. So you're getting it over the network as opposed to this really slow link. So now you're utilizing the backhaul and our cloud to get that data. And you'll get that your device every, if you, at the most, you need it every 4 hours. So if you did it 6 times a day, you're going to have a device that's always have fresh data. So if you do that automatically behind the scenes, you're no longer going to have to wait. And as you can see, the time to first fix is always going to be less than 10 seconds, which is ideal.
Mike, I can jump in here, Mike, for a couple sentences. This is really important because, like Kevin said earlier, it's about, it's really getting your asset tracker into halt or sleep mode as soon as possible to save battery power, right? And GPS was a system that was designed like back, 30, 40 years ago. And they, back then, that this wasn't really a problem. But the fact is that for asset tracking, to get those asset points, you really need to get your location and then go to sleep again as soon as possible. And if you use the traditional way of doing that, is that searching the sky for the satellites, and you don't know where you're at, okay? So you've got to search for all 32 satellites and look for each one of those. And then you have to download the data from the satellites that you actually find. That can take many minutes, as we point out on this slide. So a much better way to get this, when you have an LTE device in it like you will have, it's much better to go to the cloud and ask the cloud, first of all, what satellites are currently overhead right now? Because that's what our cloud does for you in this assisted GPS mode. It tells you that these 3 or these 4 or 5 satellites are directly over Portland, Oregon right now at your time. So don't search for the other satellites, just lock onto these, okay? And instead of waiting for the satellite to download the data to you at 50 bits per second, it's actually very insecure. Sometimes you have to wait for multiple cycles of 30 seconds to get that full almanac data. You can just download the whole thing from these satellites that you have overhead from LTE in just a matter of milliseconds. So instead of actually waiting for the 10 seconds to get your data and burning all that power, with assisted GPS from NRF Cloud, you can get that information in milliseconds and then go back into sleep mode again. So, and save a huge amounts of power. So this slide shows here that assisted GPS data from the cloud is about 3 kilobytes. So at the speed of LTE, that's much, much, much faster done. And you got to do this for at least 3 or 4 satellites to be able to triangulate, right? So for GPS. So you need to do this times 3 or 4 times. And you also probably need the almanac data, which we also supply in this mode as well over NRF Cloud, which is even bigger. Okay, so there's lots of data lots of time and data waiting in receive mode for the GPS receiver that you can save by just getting it over LTE.
And
that's what we call it.
And your team, Chris, has really pre-formatted this data into the smallest format, smallest size to fit our device, unlike other solutions that provide AGPS like Supple, who the end target device isn't an embedded device. So you're going to get a lot more data, even though that's AGPS, it's not really targeted and directly targeted to an embedded device like the 9160.
That's exactly right. So we know, of course, our GPS unit inside the 9160. So we actually do the calculation. There's a bunch of weird, numbers about satellites and they're actually orbiting and what they're doing in the time of day in different formats. We actually just calculate it for you on the cloud. So when you get the data, we send it to you in a binary blob. That's just exactly what you need to use for your interface. You just do one write to the GPS unit with that binary blob, as opposed to having to calculate all these weird things on your device itself. So the data is sort of pre-formatted directly for our API into our GPS unit. So that saves you also lots of power too as well. And actually there's lots of headache, okay, on your device and potential bugs, okay?
And here go ahead, Chris.
Yeah, so this, I think we touched this already, but I mean, this is really what you would do is that when you want to get your location, the first thing you would do, you would look in your memory and say, look, I already got this assisted data 10 minutes ago. If the data is only 10 minutes old on your device, you don't have to go through this and get the data from the cloud because it's probably still valid, okay? But if you have a timer on your device and you woke up, say, for example, 24 hours later or 12 hours later, then your best bet is the satellites probably have moved out of the line of out of the sky at this point, and then your algorithm and your asset tracker will then, first thing you would do is say, okay, I got to get this assisted GPS data one more time. And in general, I think what we're saying is that assisted GPS data is valid for about 4 hours or something like that. So after about 4 hours, you should get a fresh read from the cloud. But of course, depending upon your application, you may not need it every continually tracking. If you're doing it once a day, you can get the assistance data once a day. So it's really up to the application how much you use this service. Finally, also, of course, this all assumes, of course, that you have LTE connection. Okay, and for us that live here in this part of the world, up in the Pacific Northwest, we know that there's not always, you go off, you drive an hour away from your house, and you're in the mountains, and there's no LTE connection. And if you're doing asset tracking for a truck or something like that, that's going from one city to the other, you may not be able to get the data in 6 hours later or 12 hours later as that truck's traversing some rural area or stops somewhere for a long time. And in which case that we also have a predicted GPS feature that's coming up in the future that gives you all this assistance data, not just for the next 6 hours, but for potentially the next 6 days or even 10 days that you can store in your device. And then when you wake up, turn on, maybe a day later, and you have no LTE connection, you can still get the fix from very quickly from GPS and store it in memory. And then when you come back into LTE coverage again, you can send the location out that you had, when you were out of coverage. So this is the predicted GPS feature, which is super useful for devices that go out of LTE range, or for devices that just have enough memory and they don't want to actually get the data, assisted data every 4 or 6 hours. They can just get it for the whole week and be done with it. It's really up to the application that you're designing. And if you're tracking a dog or if you're tracking a truck, it's a different application.
And that feature is coming in Q3 of this next quarter from Nordic. the predicted.
Yeah, and there should be some beta up and running in Q2 on that, but the real that's about Q2, Q3, something like that. Yeah. And remember, this stuff is all right now. It's all for, as all the Nordic tools, we have a free tier mode. So if you want to start using this and get used to using it, it's up there to use. You don't have to, it's all for free to try out and optimize your design.
And then the 2D fix, this is just a way, traditionally you need 4 satellites to get a real accurate fix. But if you're somewhere like Chicago, which is a famous urban canyon between buildings, or depending on your angle of where you're at, you might not be able to see enough satellites to get a fix. And so the thingy or the 9160, whatever device you're using, would be waiting till it picked up a 4th satellite. Here with 2D GPS, you can sacrifice some resolution, but with 3 satellites, you could get a fix. And if you knew your altitude, like if you were on the coast somewhere like most of our big cities are, you could use this to really still get really good GPS positioning. So it's just another tool to help you depending upon your conditions. If there's raining, or as Chris said, different places you might not have the same kind of coverage.
Thanks, guys.
Well, I did want to add one more thing that I forgot to mention is you can also use the cell towers to get your location. So you know where each cell tower is by its ID, and you have a database. So in some situations, you don't need the satellites. You could still get your location just by using the tower with simple lookups in using NRF Cloud. So that's kind of one way to get an initial location where you don't even have to use GPS, which is more power hungry. And if you leave, I think you alluded to geofencing. If you're out of a certain area, you could say, hey, I want to switch to now use GPS. So that's another kind of location tool that you could use that's more cellular than GPS. And we'll have more features like that coming in the future. But go ahead, Chris.
This is also available on our cloud now via just pure REST calls, API calls that you can use today. This sort of cell-based location, single cell or multi-cell location. And this is, of course, very useful for devices that go indoors, okay? I think that's another big one. So if you have a GPS, obviously, you have to have a clear view of the sky. But if you're a truck, you go inside a garage or something like that, you need to know where it's at. And so you can use this if you can't get any satellites at all, and you can just get your location. It's more coarse, of course, than a GPS fix, but super useful for applications where you're maybe indoors or you're in a tunnel or something like that, right? So, or in an urban canyon, like Mike points out.
Thanks, guys.
Sure.
So that overview brings us naturally to the next feature, which is location tracking for our asset tracker. There are noted limitations when it comes to a purely GPS-based solution. As mentioned, indoors will impose a problem. The signal will more than likely not get through the roof. You can have dense city multipath issues. As mentioned, the urban canyon problem with Chicago and New York. As well as a truck or a vehicle almost acts as a Faraday cage when you have your devices in there in terms of GPS. You can still get cellular connectivity, but you're more than likely not going to get GPS, any sort of GPS reception. So how do we design when GPS is not possible? GPS signals are also very weak. We have to remember that this is an older technology from satellites that are coming from space. So typically, the signal that we receive on the ground is around minus 125 dBm, so it requires an extreme amount of sensitivity just to pick up the data. You can also have poor orientations with your antenna. Antennas will always have higher sensitivity and lower sensitivity lobes in terms of where they are most sensitive to reception. And if they're in the wrong orientation, or if they're near a human body or other masses, that can affect the tuning and sensitivity of your GPS antenna. There's also, GPS can consume power. There are definitely ways around it, but GPS in and of itself as it stands is a constrained it consumes a lot of power, and it can be difficult for constrained or low battery conditions where you're likely going to prioritize your wireless connectivity and reduce your GPS usage. So what do we do in a situation like that? As Mike and Chris had alluded to, LTE Location is a great option. On the right-hand side, you can see us. This is actually a screenshot from the NRF cloud to show that how it can map cell ID to a location in Vancouver. So in the center of that circle is actually where the MistyWest office is. And the accuracy of this will depend on the density of towers that are in and around the location of your asset. So in a dense urban area, you're actually going to get better accuracy in your location than a more sparse network, say out in the suburbs or farmlands. But the great thing about LTE Location is it's essentially free. You're just sending the cell ID as a RESTful API to the NRF cloud, or you can. There are other ways to do this as well, and you can get a pretty good coarse resolution location, so around 800 meters or worse. There's no sensitivity to orientation like GPS, and it's available as long as you have an LTE network. And so it's a great way to first approach getting location. Second, BLE. I'm a BLE guy, so I try to throw BLE into every design I do. And I know that makes some of the engineers here sick, but I talk about BLE every day, and so I'm going to be talking about it right now. BLE, if it's available, BLE is a great way to go. You can connect to a mobile phone. All of our mobile phones right now in our pockets, they have a location of where you are right now. And if you can do connectivity over BLE, you can leverage that. You can just use the phone's location. You can even use the phone's modem and update the cloud if there is the right app on that phone. So BLE is a great low power way of switching off some of the higher power operations on your asset tracker. It doesn't have to be a mobile phone. There are also BLE gateways. Companies like Cisco design gateways for companies so that you can do indoor location of asset trackers. And it is a great way of being able to operate an asset tracker in indoor locations at extremely low power. Wi-Fi. So as I mentioned, all of our phones have our location, and I bet for 99.8% of us right now, they're getting that location based on Wi-Fi, not GPS. Wi-Fi for location works as you're scanning for nearby Wi-Fi public access points. You're capturing the SSID and MAC address, and you're forwarding that to Google Geolocation Services for location. I mean, accuracy will vary between 5-10 meters depending on the size or the strength of the access point. But you can do this at a very low power compared to a raw GPS scan. If we're doing a Wi-Fi scan, let's say around 45% duty cycle, the current consumption during that scan is about 9.17 milliamps. This is based on some standard Wi-Fi radios. As mentioned, a GPS search is about 40 milliamps peak minimum. So as you can see, the average current during operation is about 5 times less. And considering a Wi-Fi scan can generally be done in about 10 seconds versus a cold GPS search, which can take minutes, the actual power consumption is orders of magnitude less, in and around 25 microamps. Again, this is just comparing a Wi-Fi scan to a raw GPS scan. This isn't including all the GPS features which we had previously mentioned in terms of AGPS or GPS 2D. So as you can see, 5 times less operating current from raw GPS and 25% lower in terms of lower power. And as you can see in the graphic, one of the best providers of Wi-Fi location, especially in Vancouver, and I'm sure in Portland and Seattle, Starbucks. There's public Wi-Fi's everywhere, and I bet you a lot of our phones have tracked our location simply because of a wonderful Starbucks near us. So not just a great caffeine source. So again, AGPS is another way of getting around marginal GPS location or GPS conditions. So as mentioned previously, we would grab the AGPS data over the LTE network and drastically reduce our time to fix. That can really help in marginal conditions where the GPS is just on the border of being able to operate as it normally would. So sort of tying this all together, the best way to approach location tracking, we feel, is having a state machine. So first of all, LTE Location, it's free. essentially it's free in terms of power consumption because you're going to be connected to the network anyways. So generally adding the cell ID to get a free course location is a good way to go. If you have BLE data available or BLE connectivity available, that's definitely a great way to go. I mean, average connection over BLE, depending on how much data you're pushing through, we're talking, microamps, in around the same order as a low or high latency LTE connection. The next is if there's no BLE available, we can do a Wi-Fi scan. That's done on, like I mentioned, on all of our phones when it comes to trying to get location. If we have valid GPS data, AGPS data, we can use that to then try to acquire GPS fix, assuming that parts 2 and 3 are not available. And we want to get a more accurate fix than an LTE location. So it costs about 7 microamp hours to grab the AGPS data, and then 0.06 milliamp hours to actually get the fix, which again is under 10 seconds. And then finally, once we have AGPS data, we can then leverage and try and grab the GPS data. So this sort of state machine gives you a way of sort of tiering your approach to location data. If we're able to get location through BLE, we wouldn't move on to step 3, and we've drastically reduced our power consumption while still maintaining an accurate location. And as noted at the bottom, AGPS data, it will incur data costs. Keeping data costs low is always a target for asset trackers, which is why the predictive AGPS data feature the Nordic is coming out with is going to be so powerful for asset trackers. But it is a consideration when you're designing one, is that they will impact your data costs. So naturally, the next item on our agenda would be battery powered. This thing has to last in the order of years. So we arbitrarily chose over 2 years. How do we optimize for battery life? It's measured in years. These are rarely rechargeable, if ever. Battery capacity equals size. Sales is always going to want the device smaller, and battery capacity also comes with a cost. We want to keep the cost of our product down. So as sort of hinted at before, multi-radio connectivity approach is a great way of doing this. If there's a secure BLE connection available, that is a great way of being able to operate your device, for example, indoors, or if it's in the hands of somebody that is a secure person, they have an app on their phone, we can operate our asset tracker strictly over Bluetooth, and we don't even need to worry about the other functions. We still recommend sometimes that you keep your LTE connection active, because it also is so low power, you might as well keep the LTE network alive. And it's also possible that you'd want to have extra data sent from the asset tracker, not just the phone. But we can also leverage the BLE gateway or mobile phone's location to further reduce power. As I hinted at before when I was talking about sensors on asset trackers, motion tracking is a very powerful way of assessing the current state of your device. It could also allow you to decide, maybe in some cases, to skip acquiring GPS. I mean, if your device has reported a valid location and it has not moved, why bother acquiring a new GPS fix if, let's say, you have a timer running and you want to grab a fresh location every 5 minutes? Well, you can skip that power consumption step because you know that the device is not moved. You can also use this to trigger different modes for your device. Machine learning is a very powerful feature that's coming into low power applications. It's something that was never really realizable on battery powered devices, but there's emerging technologies that will allow machine learning to be implemented on a motion tracker so that we can detect specific and even complex motions: walking, running upstairs, car movements, specific gestures. We've even designed a wearable here at MistyWest which counts punches and tracks different kinds of punches. So machine learning and low power applications are very powerful. And we've utilized ST. They have machine learning cores in their IMUs, as well as you can do this in code. Nordic is partnering with Edge Impulse, which is a great way of being able to set up your training sets and ultimately compile decision trees, which can then run as code on Nordic processors. So either way are both great ways of getting machine learning into a low power application. As talked about before, leveraging a state machine like this for location tracking is a great way to power optimize, keeping location tracking on, keeping it accurate, but reducing the power consumption as much as possible. We're going to talk about how to keep this device small. Sales is always going to say, we make this smaller. I apologize to any salespeople on the call. I don't really mean to call you guys out over and over. But the challenge is always, when we create a device, can we make this smaller? There's external antennas and internal antennas, and these play a large part in the size of our overall device. Any RF engineers on the call will always know that we are generally told how much space we have allocated for an antenna and how much ground plane we have to make the performance optimal. And oftentimes this is done towards the end of the design, not at the outset. And that's the frustration that or the cross that we bear as RF engineers. But I'm covering this just for an overall scope. External antennas often have better performance. Size is less of a constraint. It also allows for variable antenna placement and oftentimes less prone or more immune to ground plane sizes. Internal antennas are great. They can often be plug and place, but especially if you're talking about chip antennas, there is going to be a performance versus side trade-off cost, and oftentimes it's tied to how big you can make your ground. But if you're trying to make your device smaller, your ground size is going to reduce. Another challenge is that LTE antennas, to really make a globally operational wireless device, you need multiband support. Like bands 1 and 12 are just examples of bands that are covered in North America. And that means that you need to have an antenna that can operate at 2.1 gigahertz, but also down to 698 megahertz. That's a pretty wide range for an antenna to operate. So requiring multiband support so that you can support all the bands that your modem can also support, as well as making it globally operational, is very important. There's also GPS and BLE and Wi-Fi antennas. GPS, for example, the L1 band is operating at 1.5 gigahertz, and our standard BLE and Wi-Fi antennas are always at 2.4 gigahertz. So, I mean, realistically, we have potentially 3 different antennas and one with multiple band support. So a nice way around that, integrated antennas. There's always going to be pros and cons to an integrated antenna approach, but oftentimes the pros outweigh the cons. So you can make them very small. Ceramic antennas are technology such that it allows for a smaller antenna versus, say, our standard stubby antennas or a metal stamp antenna. I won't get into the physics behind that, but if anybody has questions, I'm happy to answer that during the QA. They can also be quite cost effective, and they have good efficiency. I mean, they wouldn't make them if they didn't actually work in the real world. No one would buy them. Another advantage for any designers out there is that if you decide to go with an integrated chip antenna, more likely than not, the antenna provider will actually provide tuning services for your device, which is free and great, because RF equipment, as most people know, is extremely expensive, and an anechoic chamber is in the millions. And so if you can't afford that, going with integrated antennas is a great approach to not only reduce costs in your device, but reduce your NRE costs. The integrated antenna that I have shown here is actually the antenna that's used on a Nordic development platform called the Thingy 91, which I will reference later. But it has global LTE support as well as GPS, and it is in a fairly small form factor of 30 millimeters by 3 by 1. It's off the shelf and requires no customization on the antenna to work. Cons, I mean, I would be remiss to if I didn't mention that anytime you have a master of many things, or sorry, a device that's good at many things, it will be a master of none. And if we had to compare a integrated multi-purpose antenna to fit-for-purpose antennas, the fit-for-purpose antenna's performance will be better in the bands that they are designed for. But the fact of the matter is, LTE has a great range. LTE Cat-M1 protocol has a great range, especially if you're using a device that has a high output TX, or high output transmit power rather. You got a lot of link budget to work with, and so you can deal with a slight degradation in performance because you have such a great link budget. And that is a reason why integrated antennas are such a powerful aspect to reducing size and design. And so we can do all that, and the sales will still come back and say, yeah, but can we make this even smaller? And so another thing that determines size is battery size. So if we were able to implement all the power optimization design tips that we've mentioned in this presentation, for example, the dynamic use of EDRX and PSM modes, using a state machine for location tracking, choosing components that are extremely low power, we can get well over 2 years of battery life on a standard, say, 1200 milliamp hour battery. Integrated components as well reduce the overall footprint of components needed on our PCB. It reduces parts count, which actually also reduces part management costs on the manufacturing side of things. And integrated components also have multiple functions. So it can reduce your part count, reduce your overall size, and get this smaller size that we're kind of looking for. MistyWest, for all these cellular devices that we've designed with so far, they've all actually used the Nordic NRF 9160. As you can see on the side, it's extremely small chip. The slide is not to scale because it's 16 millimeters by 10 millimeters. It has global LTE Cat-M1 NB-IoT support as well as GPS. Maxes out the front end that is allowable on the LTE Cat-M1 spec by having a 23 dB output. It has the lowest radio consumption in its class at about 50 to 90% lower than existing solutions that we've looked at. As an example, we can have a 2.5 minute EDRX interval, and we're down around 18 microamps, which is, again, in around the same consumption as a Bluetooth connection, which is truly an incredible amount, or incredible technology that we can work with here. It also includes a Cortex M33 application processor, which is great because oftentimes when we've designed asset trackers in the past, it's just an AT command interface to a radio. We couldn't actually run code on these parts. We'd always have to have an external processor. And as I mentioned in the previous slide, integrated components can reduce your parts count and your overall real estate size. So having this on board is very, very powerful, as well as it supports Zephyr. If you haven't heard of Zephyr, you will soon, because it is one of the most powerful low-power RTOSs that is currently emerging. I truly believe that it is going to be the major competitor to free RTOS in the coming years, especially for low-power wireless devices. Some other things about the 91 is security is important with cellular IoT applications. It includes industry standards in terms of such as trusted ARM trusted zones, ARM crypto cell. As I mentioned, small size, 16 millimeters by 10 millimeters, includes many of the parts that you would normally have to implement in a design as well. For example, your power management system, RF front ends, so you don't have to have an external PA, includes passives and crystals. So everything's in this one part, and we find it great to work with. And it supports any SIM or eSIM, and multi-band global coverage, and it's a pre-certified SIP. It's a great start to work with. And this is the map of where it's currently supported in the world. So if we're talking about North America, Europe, Asia, Australia, most of South America, it will be supported and will run. I had mentioned Zephyr, and I guess I wanted to expand a bit upon that. It's a project from the Linux Foundation. It's a real-time operating system, and from the ground up, it was focused on low-powered embedded devices. It has extremely small footprint. You can get it down to as low as 2 kilobytes is the floor. Typically, it'll be in around 8 kilobytes, depending on your application. But it's extremely scalable in terms of memory footprint and how you want to scale up your kernel. It's open source, which is always great, and it's our preferred method of coding at MistyWest. It was developed with security in mind, which is a good standard that is always ubiquitously part of the Linux Foundation. Well over 200 boards are supported. Nordic supports this through a fork called the NRF Connect. The latest release is coming out soon, which is version 1.5, I believe, Mike?
That's correct. It's out today. It's out as of last week.
Oh, perfect timing. Growing library support, tons of samples. I mean, if anybody's worked with Nordic in the past, and one of the reasons we always like to work with Nordic parts is there's tons of samples and tons of support to get your application up and running. So if you wanted to use Azure, AWS, firmware over there updates, all the code samples are already there for you to start with. And one of the great ones is that it already includes an asset tracker application. So for the purposes of this presentation, it's a great start point if you wanted to sort of play around with your own asset tracker application. This is I highly recommend starting with this application. A little knowledge is a powerful thingy, and this is the Thingy 91 that I'd mentioned previously. The Thingy 91 multi-sensor cellular IoT development platform. So it has the NRF 91, it has a Bluetooth chip on board, it has all the integrated antennas, several different sensors, 2 different IMUs if you needed. Pretty much everything you would need to start off, just if you wanted to get up and running just to learn the code, or if you wanted to get something that you actually work with in the field. We've actually have customers who are using this development platform for their alpha and beta trials because it is already such a small, optimized piece of hardware that it is great for us to develop on, and they can actually use in the field. So if you have a client who's looking at trying to get a cellular IoT application in the field, but they're scared about the upfront hardware costs, you can actually put one of these in the field. It's very small, and you can get this to be very, very power optimized. So I guess just to summarize what we've talked about today. So our asset tracker, we needed wireless connectivity, multi-city coverage. LTE Cat M1 was definitely the right solution for that. Real-time tracking with acceptable latency. Well, if you're able to implement a multi-mode EDRX, as well as having a smart network selection, you're always going to be able to implement the power-saving features that you need, and you're going to be able to reduce your data costs as well. There's several different cloud solutions. Always go with the one that you know best. NRF Cloud or NRF Connect for Cloud is a great way just to get something up and running, and there's a lot of out-of-the-box features. For location, always have a state machine. Oh, don't rely on one thing. So LTE Cell ID, that's free. If you have BLE, great. You can use the BLE real-time services, real-time location services. Wi-Fi is a pretty standard AGPS or assistant GPS technology. AGPS data from the cloud, as well as finally raw GPS operation. Using the design tips that we have talked about today, as well as using an extremely low power component like the NRF 9160, easily can get us 2 years of battery life or more. And that really concludes our presentation for the day. I hope it was informative, and I hope that it wasn't too dry, but it covered all the questions that you might have with regards to not just picking components and specific technologies, but the real world challenge that you will face when you're trying to implement something like this. So I'll pass it off to Madison to
you
host
can
the Q&A.
keep the presentation up.
Sure.
Just in case anybody wants to go back to reference it while we're doing the Q&A. But yeah, we're turning it over now to live Q&A. If anybody has any questions for Kevin, Chris, or Mike. We have one question here, though, that somebody has from Andrew. Compared to a single band antenna, how much less efficient is the integrated antenna? Would anybody like to answer that?
I mean, it really depends on the antenna. I mean, every antenna will have its advantages and disadvantages. I mean, some ceramic antennas will be slightly larger, and they will have slightly wider bandwidth versus smaller antennas that are more that are tighter. It depends on what type of design is inside them. So it's hard to really give you an idea of an exact number. It could be anywhere from a single purpose antenna could be efficient up to say 80%, and integrated antennas can be sometimes down to around 65 or 50%. It really depends on the antenna. But the great thing about network coverage like LTE is that your link budget is so high that reduction in efficiency is more made up by the fact that you have so much link budget.
And for the thingy, which uses the Fractus antenna, which you discussed a lot about, or Fractus likes to call that a virtual antenna. Each of the bands have a different level of efficiency, and you really, when you do that design, have to qualify it. And that was the trickiest part about making such a small 6 centimeter by 6 centimeter part. it was really tough getting the efficiency on that that antenna, which by the way is also servicing both GPS and LTE. So that's even another factor in there that typically if you had dedicated to each band, it would have a much higher efficiency. And on this, it even goes down as low as 15% on some of the bands for the efficiency on the current thingy.
Some ways to help optimize it as well is having an RF switch on your front end. And then based on that switch, you can have different inline tunings to the antenna to help optimize each of the bands.
Correct.
Cool. Thanks, guys. We have a question from Andreas. How does NRF Connect for Cloud integrate? Sorry, let me rephrase that. How does NRF Connect for Cloud integrate with IoT services through AWS, Azure, GCP, and others?
Chris, give that one to you.
Let me unmute. Okay, good. So how does it integrate with other services? How does it mean integrate? I mean, right now we NRF Connect for Cloud. Actually, you can figure this out on your own if you want to. It is actually running on AWS right now. And for example, the way we've designed NRF for Cloud to say for example, you want to use Azure as the cloud to send your telemetry data from your asset tracker. So you can also, the assisted data from NRF Cloud is available over MQTT, but it's also available over REST. So you could actually have your data communicating over Azure over MQTT, and your device could just do a REST call to NRF Cloud and just use that little piece of NRF Cloud via the REST API to get the assistance data. So you could actually have an asset tracker running on a completely third-party cloud service, your own, whatever you want, and just use NRF Cloud just for the assisted GPS part only. I hope that answered your question. Did it?
All right. So we have a question directed for Nordic from Pari. You mentioned that AGPS data is served by NRF Cloud. Is Nordic going to maintain cloud infrastructure moving forward? And is a cloud subscription needed to make use of the AGPS feature?
Well, I actually saw that. I was just typing an answer to that online, but now in the real world. We do plan on maintaining it going forward. We're going to maintain it as long as we have 9160s out there, which is going to be a long time. So this is really, I mean, a supportive of our chips. So you can expect that NRF Cloud will be around as long as we support our chips, which is going to be a long time. Right now, right now it's a tool for developers. You have to actually create an account on NRF Cloud, but it's for free right now. We really designed NRF Cloud for developers to get going and get, just like all of our tools, it's for free to get started and get going. If you really want to do 100,000 asset trackers, it's not really meant for that. But we have people now that have developed with our assisted GPS, and they like it so much that they want to use it for their operational stuff. And so we are trying to, in the future, trying to support customers who want to use it for, more than developers. And it's going to cost something because it does cost us something for all the data in out stuff. So you'll have to talk to some people at Nordic. I'm in engineering, so you have to talk to our, other people and in sales about what this is going to cost. But for developers, it's for free, like all of our tools. But if you want to use 100,000 or 1 million asset trackers, it's gonna have to cost something. That's not.
So I'm in the sales side. So at around probably Q2 or Q3, you'll see that as a service that we provide, and each salesperson can work with you on what that cost is going to be. But there will be a number of different services that Chris's team is developing out and be able to access as a service.
But like I said, you can get started now for free and try it out and get that stuff going. And talk to the other guys about the pricing for hundreds of thousands of devices.
Great. So we still have time for a couple more questions. We've got a follow-up question. Can the NRF 9160 be used for pure GPS without LTE connection?
Did you just say just GPS? Yeah, it can be in a standalone mode where it's just doing continuous GPS without, but you're not going to be reporting it back to anywhere, but you can store that locally, and actually brings up a good use case when you don't have, if you're in a vehicle, say in a part of, outside of Oregon somewhere where you've lost LTE, you're going to want to store that on your device so that when you do get LTE connection, you can report back where the truck's been. So yeah, it operates without LTE connection or narrowband IoT.
Great. So I'm going to wait a second to get a couple more questions in if anybody has them. Maybe I have a question for Kevin. If you can give me an example of any asset tracking design experience during your tenure at MistyWest.
Yeah, so am I muted? No, I'm not.
No,
Okay.
you're not.
Okay. Yeah, there's been quite a few. I mean, unfortunately, MistyWest, because we're a design consultancy, we're under NDA. So two of the cooler ones I can't actually talk about publicly. But the third one I can, but just in broad strokes. So when I had mentioned asset trackers, and I mentioned Bluetooth a lot. And for many, many years, Bluetooth Low Energy was the go-to technology for key trackers. I'm sure a lot of people have heard of Tile, Tracker, Linkit, any of those Bluetooth Low Energy companies. And they all designed key trackers that required a connection to your phone, which is great. But then if you left your keys behind and your phone went out of range of, say, 100 meters, you would no longer have connectivity, and you wouldn't necessarily know where your keys were. And one of the exciting features with CAD M1 was that we could maybe make key trackers that actually can have direct cell connectivity. So if you're connected to a phone, yeah, sure, we can leverage that and be very low power and basically operate like in a tile mode. Or if the phone is away, we can still be connected to the internet and we can go straight to the tower. And so that was a project that I was very passionate about working on, simply because I'd worked in the startup space where we were a competitor to Tile using Nordic parts, and being able to take what that design was, or take the spirit of those types of designs and then really extend it to now actually having a realizable key tracker that is connecting to the internet has been very cool, because it addressed all the challenges that I mentioned in the slides. We need to make it smaller, going to need to make it smaller. We need to have the battery life in years, but the battery needs to be small. The RF performance has to be high enough, but you can only make it this big. And all those challenges were just a lot of fun to design with. So I would say the key tracker application was the most fun that I had in this particular realm.
And you mentioned something about MistyWest working on our own type of like asset tracking device.
So we have, as part of MistyWest, whenever there's an emerging technology, we always try to learn about it, and the best way to learn about it is actually just design it. So we have called internal projects. So we have internal projects where we've designed wearables, we've designed several things, and one of them is in the asset tracking space. Can't really talk too much about it, other than it is a device that's going to be about the shape of a hockey puck, because, we're in Vancouver, we're Canadians, so, we always have that bias towards hockey. So it's going to be in around like a
standard unit of measure in Canada.
Exactly. It's essentially currency up here. But the idea being is that insurance rates are going up a lot around the Pacific Northwest, and anybody who's in a condo or house is definitely feeling insurance rates going up. And leaking is always a common problem in condos, especially in Vancouver. We have a long history of leaky condos. So the idea of maybe creating an asset or a cellular IoT device about the size of a hockey puck that could do a leak detection. Pop it underneath a dishwasher or near a washer dryer, and you'd have immediate network connectivity as you detected a leak.
And for anybody that's listening right now and thinks that I'm potentially feeding Kevin lines or anything, I honestly had no idea about two of those projects. So this is all for me to learn as well. They were genuine questions. We do have another question from Hari now. Can the peak TX power of NRF 9160 be sourced from a CR2032 coin cell?
No, that is one of the common misconceptions about batteries and long-range wireless. So although the average power consumption is quite low in the order of microamps, ultimately there are still peak currents that the battery will be subject to, and there's certainly ways around that where you can design a massive capacitor bank, but ultimately a CR 2032 just will not be able to support the peak currents as you are connecting to the network, for example. So there will be momentary moments when the peak current will be quite high, and a battery like that will not be able to support it. Even though most of the time the device will be idle, and certainly a CR02, sorry, a 2032 can support the idle currents, it could not support the momentary low duty cycle radio events. It's entirely possible that you can possibly design something with a small battery and a super cap to offload radio events. It's something that we've done with some satellite devices that required extremely small batteries. But realistically, your best bet is to have a lithium-ion battery that can support the peak currents that you need.
Yeah, the thing he uses a lithium polymer that's, I believe, 1,400 milliamp hours, and it fits kind of at the bottom of the board.
Yep.
And we have had customers do some kind of charging system in a solar configuration with as you mentioned, and it just depends on, the components that they have for that design. But 23 plus 23 dB output power takes a big surge of current when you need it at certain points. So yeah, coin cell just won't do it.
All right. Well, I don't think we're going to get any more questions. So if you guys are all right with it, we might start wrapping up.
Okay. Yeah, just take a minute to say some, we've seen a number of applications as asset trackers, not talking about anything specific, but tracking animals in the wild has been one of the interesting ones all over the world, which is really cool to see, migration patterns. I know I've talked to customers in China that have implemented projects like that. So it's really unbelievable the number of things that you can do when you get the size down and the weight down on this type of product.
Agree. I'm very excited to see the what sort of products and applications are going to emerge as a result of this technology being ready for prime time.
Definitely. And it's great to have developers, because this, like what MistyWest is from Nordic's position, because we really need that in the Zephyr community, and where Nordic has gone with what we call NRF Connect SDK. It really is a great software package, and Zephyr as RTOS, as you mentioned, Kevin, is really going to grow in the space that it's in, but it takes a bit of time to come up to speed on that. So we really appreciate having developers like MistyWest out there that can help customers get to market faster. So, and it will continue to support, and that's our long-term plan now, is NRF Connect SDK, both on the cellular side, the Bluetooth side, and in the near future on the Wi-Fi side.
Okay. Kevin, if you'd like to stop sharing your screen, I can take it over and I'll start sharing mine. Is it presenting? It is not yet presenting. Oops. It's showing you my, okay, 1 second. Whose screen? Oh, we're looking at Kevin's screen. Okay, that explains what's going on here. All right.
There we go.
I was like, why won't it present? Yeah, I would like to thank Nordic for partnering with us on this event. I'd also like to give a shout out to Kurt Waters, who's behind the scenes. He was kind of the initial one who proposed doing this educational seminar. And yeah, I would like to thank everybody that has been on our panel today. It's been a really great discussion. I, for one, have learned many things regarding IoT and cellular IoT and like network connectivity and I'm always trying to expand my technical knowledge during my time at MistyWest. For anybody that is interested in potentially speaking at one of our webinars, sponsoring one, or has a suggestion for a topic, you can reach out to me, Madison at mistywest.com. You can also reach out to me on LinkedIn. I want to post one of our blog posts in the chat for anyone that might be interested. It was written by our engineer, Justin Lamb, but he consulted a lot with Kevin Lockwood on the actual like technical expertise in the blog post. So it covers a lot of what was touched on today on low power optimizations. Our upcoming Vancouver hardware meetups over the next few months we're trying to move more to like a monthly schedule, and as of right now what we have slated are agri-tech ecosystems for later this month, something related to Earth Day in April, and a neurodiversity inclusion in tech event in mid-May. And I just want to let everybody know that MistyWest is currently hiring a mid to senior level IoT software engineer. You'll see that our co-founder, Lee Christie, left a comment in the chat regarding this as well with a link to our careers page. So please feel free to visit the MistyWest careers page to learn more about this position and to learn more about working at MistyWest. We're also always collecting resumes and applications for potential future opening positions. So please feel free to take a look, even if you're not currently a fit for what we're seeking.
I put my email address in the chat as well. I eat, sleep, and breathe Bluetooth and cellular IoT. So if you want to contact me on a Sunday night, I'll probably get back to you. So if you have any questions that come up later, or maybe you didn't want to ask during the open panel, happy to address them. So shoot me an email anytime.
Yeah, and I want to thank everybody that attended today's event and that stayed until the end. Thanks to everybody that had a question. This was really great. And I want to thank our panelists again for offering their input, and to Nordic overall. And if anybody has any information they want to share before I close it up, or shall I just bid you adieu?
I'm good. Have a good week, guys.
Thanks. Thank you.
All right, thanks.